I'm Anil Kumar, and here is another excellent question from my student who wants to understand probability relating to geometric distribution. The question here is Sam has a success rate of 75% for scoring on free throws in basketball. What is the probability that Sam will not miss a shot until his 10th free throw? B. What is the probability that Sam will miss second shot on his sixth free throw? And C is what is the expected waiting time before he misses the basket on a free throw? Now, let me share with you the actual concern why this question has come to me. The idea here is that you have learned in geometric probability, geometric distribution probability, that probability of success, let me write down, probability of success after waiting, that is when we talk about geometric probability of waiting X failures, let us say, is what? So in that case, the probability of success is equals to q to the power of x times p. Now the real question is that the student is using this formula but is not getting the right answer, right? So that is the real question. So we'll actually address this question also while answering. So let me show you first not to use formula but use alternate method. And then we'll get back to formula also, right? Which I say logic. In probability, we could apply logic many times. Okay. It says Sam has success rate of 75% for scoring. That means probability for scoring is 75% and probability for not scoring is 25%. Is it okay? So let me write down without success and failure that probability of scoring is 75% and probability of not scoring is then 1 minus 0.75, which is 0.25. That's clear, right? Now what is the question? It says what is the probability that Sam will not miss a shot until his 10th throw? That means missing on 10th throw, right? That really means missing on 10th throw. That means 9 he scored, right? So let's say, let me write down here. 1, 2, 3, 4, 5, 6, 7, 8, 9 is perfectly fine. And then Sam missed on the 10th. That is the situation. Now what we know here is that we have independent events, right? Therefore, their probability should be multiplied, right? So what is the probability that Sam will not miss? That means he'll score, right? So that means probability of scoring, which is 0.75, and it goes 9 times. So 9 such things, right? And this is not scoring, which is 0.25, correct? So this is also 0.75 and the same way till here, 0.75. So you could say, since they are independent events, it is 0.75 to the power of 9 times 0.25. Is that clear? So we can write down our answer here, which is 0.75 to the power of 9 times 0.25 equals to, the answer here is, let me write down in a different ink, is equals to 0.01877. Let me write 8. Okay. So that becomes the answer. Now, how do we check this answer with the formula given to us? Right? Now, in the formula, you have to be very clear what is treated as success and what is treated as failure. Right? So, in this case, we are looking for missing. So missing is success. Do you see that? So in this case, missing is success. We are waiting for missing, and therefore the value of P actually is, that is a success, right? So missing is only 0.25, and failure Q is not missing. That means, as per the question, not missing. Do you understand? So because these two, I should say, variables have been interchanged in the question so phrased, at times you may land up into problems, right? But that's the true story, right? So we are waiting for failure of scoring. Do you understand? Success is failure of scoring, right? And scoring is a failure here. Waiting, right? Waiting for not scoring. So I hope now it's absolutely clear. So that is how they're linked, okay? Now, part B is, what is the probability that Sam will miss second shot on his sixth free throw? Well, that is interesting. So what we have here is, we have 6 throws. 1, 2, 3, 4, 5, 6. And we know this is miss. So I'm not using P and Q. I'm using missing and not missing or scoring. Is that okay? So it says, what is the probability that Sam will miss second shot? So first, Sam could miss anywhere. So for missing, we are saying probability for missing, right? So we know there are 1, 2, 3, 4, 5 positions, but we know for sure 6th is a miss. So that 5 for this combination gets multiplied to the whole combination, right? Does make sense to you. Now in between, wherever you miss, what we have here is that out of 6, 1, 2, 3, 4, 5, 6, there are 2 missings. We have 2 missings. And 4 scoring. Does it make sense to you? 2 missing and 4 scoring. And therefore, since there are 2 missing and 4 scoring, we could write scoring is 75%. So 0.75 to the power of 4 and 0.25 to the power of 2. So that is how we could correctly get our answer without using formulas, right? So this is 5 times 0.75 to the power of 4 times 0.25 to the power of 2. That is square. And this gives you, let me write here, 0.0987. So I could write, so that is what it is. So what is the probability that Sam will miss second shot on his 6th free throw? 0.0988, right? So you could say 10%, right? So that could be rounded to 10%. Okay, let it write 0.099 or approximately to 0.10, right? Or 10%. So that is how you could answer this question. Now the last question here is, what is the expected waiting time before he misses the basket on free throw? So let's use, we now understand fairly well, this is a geometric distribution, and the expected waiting time is the ratio of Q over P. So Q for us is really 0.75 divided by P, which is 0.25. And that ratio is 0.75 divided by 0.25, which is, as you expected, 3. Right? So we get expected time as 3. Do you see that? So we get this as 3 as our answer, and that is 0.0188, and this could be 0.099, right? So I hope now the concept is clear. Sometimes the questions are so phrased that you may take wrong values of P and Q and therefore make a mistake. But I hope now it is absolutely clear. Thanks for watching and also posting such a question. Feel free to write comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you.